rational numbers and their decimal expansion. This is my discussion here. So let's look at a rational number. What is a rational number? Let's say if you take a rational number p by q, where q not equal to 0, what we are going to do here is we'll explore exactly when the decimal expansion of p by q is terminating and when it is non-terminating and recurring. Let's consider one rational number, 0.375. Now this, if you express it as p by q, one way of doing that is you can write 0.375 equal to 375 by 1000. Now 375 by 1000, I can also represent it as 3 into 5 cube, because that's 3 into 125. 3 into 5 cube divided by 1000 can be written as 2 cube into 5 cube, because that's 10 cube. So in turn I can write it as 2 cube into 5 cube. So 5 cube and 5 cube, if I cancel out, I'll get 3 by 2 cube. So here the format is 3 by 2 cube. Now let's look at another rational number. You'll understand why I'm giving you these examples, because we'll arrive at some conclusions here. Now if I take 0.0875, that if I use a power of 10 in the denominator and express, I can write this as 875 by 10 raised to 4. Now 875 by 10 raised to 4, if I rewrite 875, I can write it as 7 into 5 cube divided by, what is 10 raised to 4? 2 raised to 4 into 5 raised to 4. So what will remain here? 5 cube and 5 cube, if I cancel out, 1 5 will remain. So what will remain is 7 divided by 2 raised to 4 into 5. So if you look at these examples, what is that you can understand? So let's discuss that. So we can easily see that any real number which has a decimal expansion that terminates can be expressed as a rational number whose denominator is the power of 10. That's what we did. The only prime factors of 10 are 2 and 5. So we can find out that the real number is a rational number of the form p by q, where the prime factorization of q is of the form 2 raised to n into 5 raised to m, where n and m are non-negative integers. So to state this properly, what is that? If x is a rational number whose decimal expansion terminates, then x can be written in the form of p by q, where p and q are co-primes, and the prime factorization of q will be in the form of 2 raised to n into 5 raised to m, where m and n are non-negative integers. If you think reverse, the other way around, 3 by 8, the same example, 3 by 8, you can write it as 3 by 2 cube, multiply by 5 cube here and here, so you'll get 3 into 5 cube is 375, and by 1000, so you'll get 0.375. That is, you can look at other examples also. Then you will get, let x equal to p by q be a rational number such that the prime factorization of q is of the form 2 raised to n into 5 raised to m, where n and m are non-negative integers. Then x will have a decimal expansion which terminates. So the point to be noted here, what is important here is, if the rational number p by q, where x equal to p by q, where q is of the form 2 raised to n into 5 raised to m, that means if it is a power of 2 or a power of 5 or a power of 2 and 5 both multiplied, then the decimal expansion will terminate, or it will have a decimal expansion that terminates. So I hope that's very clear. Now we look at a scenario where q is not of the form 2 raised to n into 5 raised to m. Then we'll see what will happen, because we know that rational numbers, when you express it in the decimal form, it can it can be terminating or non-terminating repeating, which is recurring. So we understood very clearly that when P by Q, where Q is of the form 2 raised to n into 5 raised to m, that is when it will terminate. We just so 3 by 8, because 3 by 8 where 8 is actually 2q. 3 by 8 where 8 is actually 2q, right? So we can, that's will result in 0.375, or we can have just 1 by 8. Now 1 by 8 is 1 by 2 cube, so that will be 0.125. That's again of the format 2 raised to n. Now it can be like again of the format directly, if you write down also something like 875. Now 875 by 10,000, if you take 875 by 10,000, if you take, now 10,000 is what? 10,000 is 2 raised to 4 into 5 raised to 4. That's of the format 2 raised to n into 5 raised to n m. Then that will be 0.0875. That's again terminating. So this is these examples are more than enough for you to understand when it will terminate, when the decimal expansion will be terminating. Now there are cases where decimal expansion will be non-terminating, repeating. So we will see that scenario next. So, and that is actually when in the expression P by Q, x equal to P by Q, if Q is not of the form 2 raised to n into 5 raised to m. That is, if it is in prime factorized format, if there is any other prime factor rather than 2 and 5, then decimal expansion will be non-terminating, repeating. So I'll give you an example. Let's take 1 by 7. That's very simple, right? What is 1 by 7? 1 by 7 will be 0.142857, 142857, and it will be non-terminating, repeating like this: 0.142857, 142857, 142857, like that. It's non-terminating, repeating. You can just verify 1 by 7 by using basic division, and this is what you will get. Here, this is 1 by 7 is of the format where if I compare it with P by Q, Q is not of the form 2 raised to n into 5 raised to m. Prime factorized form is not of the form 2 raised to n into 5 raised to m. That is why this is non-terminating and repeating. So it's very easy to understand. It's very easy to understand when it's terminating and when it's non-terminating, repeating. So the two important points, that is, when the denominator, when x is P by Q, if Q is power of 2 or a power of 5, otherwise I can take 2 raised to n into 5 raised to m format, then it will terminate. If it is not of the form 2 raised to n 5 raised to m, it will be non-terminating, repeating. If you want to write it down properly, let x equal to P by Q be a rational number such that prime factorization of Q is not of the form 2 raised to n 5 raised to m, where m and n are non-negative integers. Then x has a decimal expansion which is non-terminating, repeating. Now from these discussions, what is that we can conclude? We can conclude that the decimal expansion of every rational number is either terminating or non-terminating, repeating. I hope you have a clear understanding of rational numbers and where the decimal format, when it's repeating and when it's non-repeating. And we used prime factorization, that is basically fundamental theorem of arithmetic, to prove this or to understand this better. So just to practice 1 or 2 questions, without performing division, long division, check whether these rational numbers will have a decimal expansion which is terminating or non-terminating, repeating. So the first question, first number 13 by 3125. So what is that you need to verify? You need to verify whether this number 3125 is of the form 2 raised to n 5 raised to m. So 3125 is actually 5 raised to 5. That is why this one will have a decimal expansion which is terminating. So the next question is 7 by 15. Now 7 by 15, if I compare it with p by q, 15 is 3 into 5, is not of the form 2 raised to n into 5 raised to m. So decimal expansion will be non-terminating repeating. So it's very easy to check even without doing the division. It's very easy to check whether it's allow a decimal expansion which is terminating or non-terminating repeating. And I hope you're very confident of solving questions like these.